Hi, U10s. In this video, I'm going to be going through sketching parabolas using the quadratic formula and introducing that to you for the first time. And of course, we can also use what's called a discriminant to determine the number of x-intercepts as well. So first of all, we're going to be looking at we'll be looking at the quadratic formula, and then within that, how to use what's called the discriminant to determine the number of x-intercepts on the graph. And of course, we can also use using the symmetry of quadratics and parabolas. We can also sort of refer to and find the turning point, which we'll look at as well. Now, so far, we've found any x-intercepts by factorizing, and of course, we've also looked at solving and sketching by completing the square as well. Okay. Now, the thing is that an alternate method for sketching is also using the quadratic formula. For example, if we can't factorize, if it's quite tricky to complete the square, then we can use the quadratic formula. Now, the quadratic formula is just basically a shortcut to completing the square. Now, usually I would, for some students, maybe a few in each class, I would probably go ahead and prove the quadratic formula, and the rest of you will probably just go completely over your head. I want to at least talk about where the quadratic formula comes from. So the quadratic formula, we are looking at we're looking at solving. If I've got a quadratic in the form ax squared plus bx plus c, then we can is equal to 0. Then we can go ahead and find the solutions. Now, what we're actually doing is, first of all, we're basically dividing. Now, this number a at the front could be anything. So we could have 2x squared, 3x squared, etc. So we're just looking for a general case. So if I have, now of course we can only really complete the square if we've got like what's called a monic trinomial. In other words, the coefficient is 1. So the first step is we're basically dividing everything through by a in this case. Now if I divide, so regardless of whether this is 2x squared, 3x squared, it doesn't really matter because we're dividing through by this thing here. Okay, and when we do that, that's going to make this x squared. And hopefully you can recognize that although you don't need to prove this, what we're doing is we're then completing the square. So we're completing the square down here. And then what we're doing is we're then getting everything all over to one side. And when we do that, and when we finally get this x is equal to minus b plus or minus the square root of b squared minus 4ac on 2a. And this is what we call the quadratic formula. Now, if you want me to prove this and explain every step along the way in person, no problem. I have no problem doing this. But for the most part, a lot of you, this is just going to go straight over your head. But essentially, all it is just completing the square of a sort of a quadratic in the general form. Which so basically, it's getting it in this form here, a monic trinomial, and then we're basically completing the square, and that's going to give me our quadratic formula. Now, what is this a, b, and c? Well, what we're looking at is the coefficient of x squared is going to be a. The coefficient of x is b, and the constant is c. So, for example, if I was to have 2x squared minus 3x plus 2, for example, then we can go ahead and say that a would be equal to 2. B is the coefficient of x, which is minus 3, and c is equal to 2. So we could go ahead and say the x-intercepts are at, well, we can plug them into this equation. We can plug those values of a, b, and c into here, and we can use that to solve. Okay, so first of all, if we go back and look at the quadratic equation, we can hopefully see there's this what we call a discriminant, and a discriminant is actually the thing inside of the square root in here. So we've got this b squared minus 4ac inside of here, and this is what we call the discriminant. Okay, and that discriminant actually helps us determine the number of solutions. Now, it might make sense that if, for example, the first one, which is if there's no solutions, if the discriminant, which is b squared minus 4ac, let's say if it's -2, if you're trying to, if this, think about it, if this b squared minus 4ac was -2, what's the square root of -2? If you were to try the square root of a negative answer, so for example, if I was to go control divide and the square root of anything negative, well, we're going to get an error. We can't take the square root of a negative number. It just simply doesn't exist. Okay, so it's a non-real result is what you'll sort of see, or you'll see error in your green calculator. If we go back here, then so if the discriminant, we can use this, such a powerful tool that if we want to find out how many intercepts we have, well, the first one is if the discriminant, in other words, if that stuff in square root is less than 0, then it's basically saying there's no x-intercepts. And as you can see here, look, there's no x-intercepts. This graph here does not cross the x-axis. Okay, and there's actually no intercept. It doesn't cross the x-axis. Likewise, if it's greater than 0, this is a really common one you'll see that there's going to be 1, 2 intercepts. So in other words, if the discriminant is greater than 0, then there's going to be 2 solutions. Over here, there's no solutions. And then there's a unique one where it just touches, the turning point just touches the x-axis. And that's when the discriminant is equal to 0, and that means that there's 1 solution. Okay, I know that's a lot to take in, but let's have a look. Let's have a look and do a bit of an activity here. Now, all right, so let's go through an example, and I think it's going to make a bit more sense. First of all, it says consider the parabola with the quadratic equation. We want to determine the number of intercepts. So first of all, let's write out what the quadratic equation is, and you'll be given this on your formula sheets and things like this. But the quadratic equation is x is equal to minus b plus or minus b squared minus 4ac on 2a. Okay, so that means the x-intercepts, when I plug in these values for a, b, and c into this formula, we're going to find the x-intercepts. And it's basically a shortcut to completing the square. And of course, if I was to complete the square, then I would have this 3x squared. We would basically, if I were to complete the square, I'd have to take 3 out the front and then look something like this. Okay, and we could then complete the square and do that, and it's going to take a fair bit of work. So this is a shortcut to doing all of that. Okay, so we don't need to do that when we're using the quadratic equation. It's doing it all for us. Okay, so let's have a look at this. First of all, the coefficient of x squared is a, so ax squared, and that happens to be 3. The coefficient of x there is b. And the constant here is c. So let's write out what we know. First of all, we can say that a is equal to 3, the coefficient of x squared. B is equal to the coefficient of x, which is minus 6. And c is the constant, which is 5. Okay, so we're trying to, that's what we need to use into the quadratic equation. Now, it's just asking for the number of x-intercepts. So if it's asking for the number of x-intercepts, well, we're going to look at the discriminant, which is this thing inside the square root sign, okay, b squared minus 4ac. That will help us determine the x-intercepts, and that's what we call the discriminant. So let's write it out. The discriminant, which we use sort of as a triangle as the discriminant, is equal to b squared minus 4ac. Now, we've listed what A, B, and C are. A is equal to 3, B is equal to minus 6, and C is equal to 5. So if I go ahead and do that, then and put all of that in, b squared is minus 6 squared. Be very careful. Minus 4 times a, which is 3 times 5 times 3 times c. We're putting that into that equation. Now, minus 6 squared is positive 36. And then we've got minus 4 times 3 times 5. 3 times 5. 3 times 5 is 15. And that's going to be minus 15 or 60. So it's going to be 36 minus 60. So it's asking us to determine the number of x-intercepts. Well, the discriminant is equal to negative 24. Well, what did we talk about before? Can I do the square root of negative 24? No, there's no solution. So if due to the fact that the discriminant is less than 0, there are no x-intercepts, basically. There are no x-intercepts. Okay? If it was greater than 0, there would be 2. If it was equal to 0, there would be 1, as per this page here. So it's really important. I think that something like this really needs to go in your bound reference for sure. Okay, that needs to be handwritten in your bound reference. Okay, so we've found that there's no x-intercepts. So, and look, if I was to sketch this, hopefully I can see, if I see 3x squared minus 6x plus 5, if I was to sketch that in my CAS calculator, let's go over here. We want to go, so I've got 3x squared minus 6x and then plus 5. And as you can see, look at that. It turns, it doesn't cross the x-axis. You can see there that there's no x-intercepts. Turn the y-intercept, well, that should be the easy part because the y-intercept, we let x equal 0. And of course, this is in this form here. So we've got y 3 times 0 squared. Well, look, 3 times 0 squared minus 6 times 0 plus 5 is just going to be that constant there, isn't it, which is 5. Okay, so we know that the y-intercept is 5, and it's going to look, well, we've sort of seen that it goes something like this. Now it says use x equals minus b on 2a to determine the turning point. So whenever you're using this quadratic formula, there's another rule here, which is the turning point is at minus b on 2a. So the x-coordinate of the turning point is at x equals minus b on 2a. Well, what is b and a? Well, if I go back to here, we've got that a is the coefficient of x squared, which is 3, and b is the coefficient of x, which is minus 6. So if I go x is equal to minus b, which is minus, be careful, minus times minus 6, on 2a, which is 2 times 3, and that's going to be a negative times a negative is a positive. It's going to be positive 6 over 6, which is equal to 1. Well, what does that mean? It means that at x equals 1, we have a turning point. Basically, it goes down here. It's going to go down here. And, of course, we have found that that is 1. Now, of course, we don't quite know yet what this value is here. Well, how do we find it? When x equals 1, we're going to have to sub into our equation. Y is equal to 3x squared. Well, that's 3 times 1 squared. Minus 6x, minus 6 times 1. So we're substituting that into the equation. Plus 5. 3 times 1 is 3 minus 6 plus 5. 3 plus 5 is 8. 3 plus 5 is 8, minus 6 is 2. So there you go. We're looking at, and we've now, because there's no x-intercepts, we've found that, we've determined that by using the discriminant, and we've just got the y-intercept and the turning point. You can see there that we've actually now sketched our graph. Our graph is going to look like this. We've got our turning point, and we've got our y-intercept, and that's what it's needed. Okay, now that I've been through that, we're going to give you a very similar question, and this time I'm going to get you to try. So I'd like you to, I'm going to leave that up there. I'm going to pause this video now, and I'd like you to, I'll pause this, and if I'll get you to pause it and to give this a go, and I'll reveal my answers shortly. All right, so I've done the first two there. Determine the number of x-intercepts. In order to do that, we're going to have to use the discriminant, which is b squared minus 4ac. And we've got to first of all identify what a, b, and c are. So a is the coefficient of x squared, which is 2. And b is the coefficient of x, which is minus 4. And c is the constant, which is 1. We're putting those together in the discriminant, and that's going to be minus b squared is minus 4 squared minus 4ac, which is minus 4 times 2 times 1, which is minus 8. 16 minus 8 is 8. And because the discriminant is greater than 0, there are 2 x-intercepts. We're not actually asking you to find those yet. We'll get into finding those in a sec using the quadratic equation. But for the time being, we're just sort of asking then, what is the y-intercept? Well, the y-intercept is when x equals 0. So subbing that in, 2 times 0 squared minus 4 times 0 plus 1. Notice that the plus 1, it's in this form, well, that constant there is going to be the y-intercept. Okay, and finally, we've got finding the using x equals minus b on 2a. X is equal to minus b on 2a. That's going to be the x part of the turning point, and the turning point is going to be minus b, which is minus 4 on 2a. 2 times 2, that's going to be 4 on 4, which is 1. So now if I was to do my sketch, we can hopefully see that, yes, there are 2 intercepts. We won't worry about what they are for the time being, but we're going through y equals 1, and our turning point is at x equals 1. So our turning point is at x equals 1, and when x equals 1, y is equal to, let's substitute that in, 2 times 1 squared minus 4 times 1 plus 1 is 2 minus 4 plus 1, which is 3 take 4, which is negative 1. So look, we've got a turning point there at 1 minus 1, and it's going to go something like this, and it's sort of going to turn, and it's going to come around here. There's going to be, we've got 1 minus 1, and later on we're going to look at finding those 2 x-intercepts. Okay, so at the moment we're sort of looking at the discriminant and using that to find the intercepts, and then using this new rule x equals minus b on 2a to find the turning point. Now, this time it's asking us to sketch the quadratic, labeling all significant points, and of course we can't. So first of all, a lot of the time with these, I'll probably ask you to use the quadratic equation, because can we factorize? Well, it's not a monic trinomial because there's a 2 here. It's also going to be very hard to complete the square, because we can complete the square, but because of this 2, that's going to make life a lot difficult. So in this case, we're going to, rather than do this, we're going to do it, rather than do it this way or this way, we're going to use the quadratic formula. Okay. Now, determining the significant points that we're going to have to find the turning point. We're going to have to find the x-intercepts and the y-intercepts, x and y, and when we do all of those, now that's all of our significant points. It also says to round the x-intercepts to 2 decimal places, so we're okay, we can do that. Okay, so where do we start with this? Well, first of all, let's write out what the quadratic equation is. The quadratic equation is, which you should have on the formula sheets, and eventually you should almost be able to commit it to memory. Minus b plus or minus the square root of b squared minus 4ac on 2a. And in this case, we're looking at, I'm going to rub this out, and we're going to have, you can see here that the coefficient of x squared is a. So a is equal to 2. And you need to identify this straight away. B is equal to 4, and C is that constant. Don't forget the negative. C is equal to negative 3. Now, let's determine if there are any x-intercepts. And the and we're going to need this for the equation anyway. So first of all, because we're going to need to, when we do all of this, we're going to need to work out all of this, which includes the discriminant, which is inside the square root. So if we use the discriminant first to find that out, we can sort of determine, we're going to need to know that anyway. So if we work out what the discriminant is, b squared minus 4ac, and we're going to do that now, that will tell us how many intercepts we're looking at, or if any at all. So b squared minus 4ac, well, that's going to be b. B we've established is 4 squared. Take away 4 times a times c, 2 times minus 3. 4 squared is 16, minus 4 times 2 is going to be minus 8. Minus 8 times minus 3 is positive 24, which is 40. Now, because we know that that's not negative, so negative would have no solutions. If it's greater than 0, hopefully you can see that that's going to mean that there's 2 solutions, or 2 x-intercepts. Because now, if I want to do the quadratic equation, x equals minus b. So it's minus b, which is minus 4, plus or minus the square root. Now, we don't need to, we've done all of this. We've worked out what this is. That's 40. Okay, that's 40. So we put in 40 into there. And then let's go into 2a. 2 times 2 is 4. Okay, so the thing is that we might have been able to factorize this, but you'll probably find that that we can well, let's simplify this now, because we've just sort of done surds recently. Hopefully you can recognize that root 40 is the same as 10 times 4, because 4 is a perfect square. Okay, and then if I bring that out the front, we've got 10 times 4. Square root of 4 is 2, so we've got plus or minus 2 root 10 over 4. Okay, so we've now simplified that. So what we're saying is that there's 2 x-intercepts. There's one at minus 4 plus 2 root 10 over 4. And likewise, there's one at minus 4 minus 2 root 10 over 4. Clearly, there's 2 unique solutions. Now, we're asking you to do that as just a decimal. Okay, so let's go ahead and let's go back now. That's your exact answer. If I've got, so if I go to here, and then I've got to go minus 4. Let's do it in 2 separate ways. Let's do it like this. Let's do control and divide, get our fractions up, and minus 4 plus 2 root 10 over 4. Now that's going to give you that. Let's go control and 0.58. 2 decimal places, so that's going to be 0.58. Let's do it to 2 decimal places. So there, let's mark that out as somewhere around about here. Somewhere around about here, and let's go, that's 0.58, 0. That's 1. If I go though over here and do the same thing, but now this time I'm going to go across here, I'm going to press enter, copy it down, and all we're going to do is we're just changing this minus 4 plus and minus 4 oh dear. Okay, let's try. Press enter again, and over here I want to delete that, and I want to do press up, press enter. This is doing some pretty strange things, but I'm going to delete that, and I'm going to go minus, enter. Look at that, minus 2.58. All right, so minus 2.58, which is somewhere over here, just a little bit more, minus 2.58, something like there. Okay, so that's minus 2.58, 0. Now, if I then do, well, the y-intercept is the easy part, isn't it? That's when x equals 0. That's this thing, which is minus 3. There you go. Now, of course, I've got one last thing to do, and that is find the turning point. So we've found my 2 x-intercepts. We've got the y-intercept, which is at 0, minus 3. And of course, we're going to find the x part of the turning point is at, we're going to say x equals minus b on 2a. So we're going to have to find that first. So let's do that. Well, we've got a is equal to, what did we establish was 2. So, and b is 4. So it's minus 4 on 2 times 2, which is minus 4 on 4, which is negative 1. Okay, so x equals negative 1. Halfway between those 2 points is the intercept. So in other words, our intercept is going to be sort of somewhere on that line, our turning point, sorry. And now what we need to do is when x equals minus 1, let's go ahead and find the rest. Y is equal to 2 times minus 1 squared plus 4 times minus 1 minus 3. That's going to be 2 times 1 plus minus 4, minus 4, and then minus 3. 2 minus 4 is minus 2, minus 3 is minus 5. So we've now got, there you go, we have our turning point. And now let's trace all of the points together. So it comes through here, comes down here at approximately 0, negative 2.58. It sort of turns about here. It goes through the y-intercept of 3, 0.58. Look at that. Isn't that just fantastic? And we've got x equals minus 1 and y is equal to minus 5 is our turning point. We've got all our points labelled, our turning point, our 2 intercepts, correct the 2 decimal places, and our y-intercept. And we are done. So I'm going to get you to practice now. I've got a very similar question here, and I'm going to get you to try this now. Now, this is, you really can't skip too many steps. Let me talk about, first of all, step 1, we need to identify that we're going to use a quadratic equation. Generally speaking, we might ask you to specifically use a quadratic equation. If you're going on to methods next year, you'll need to I guess, identify when you can't factorise or complete the square, and you'll need to use this. Okay, step 2, I think work out what the discriminant is, okay, because you're going to need that when you're doing the quadratic equation anyway. So you've established that that's 40, which means you can go into there, and that means that we've got 2 solutions, i.e. 1, 2 solutions. Then from there, use the quadratic equation, and we can simplify. And of course, this, we wanted to get these to 2 decimal places. So we needed to calculate that exact answer in a calculator to get a decimal approximate. And then from there, we had to use the fact that, so once we've done all of that, step 3, step 4, we have to find the x part of the turning point using this rule here. And you can see there's quite a few steps involved. And then from there, step 5, we had to find the y part. And once we've got the x and the y part, then we can sketch everything together. And as you can see, we're looking for once you have all those bits of information, you can piece them all together and get a nice sketch. Okay, now I'm going to leave that up there. Okay, and hopefully you can start and have a go at this next one. Pause it now, give it a shot, see how close you get, and I'm going to reveal my answers shortly. All right, so again, this sort of 5-stage process. First of all, we need to identify what A, B, and C are. We've got that A is 3, B is -6, and C is 1. We're then using the discriminant to find how many turning points we have. When we do that, -6 minus B, -6, all squared, minus 4AC gives me 36 take 24, 12, which is, 24. That means that there's 2 x-intercepts. Boom, there they are. And we can then go ahead and find those using the quadratic formula. Now, we've already found what that is. So that's going to be 24. So the quadratic formula minus B minus -6. Be careful of that double negative. Plus or minus, we've already found our answer to that, which is 24. Plugging that into the formula gives us this, which we can simplify to that. And of course, then put that in your calculator. You're going to need to do that. You're going to need to use your CAS for these because it can be quite tricky to do that in the green calculators. That gives us 1.82 and 0.18. So there you go. There's my two x-intercepts. The y-intercept is the easy part. That's when x equals 0. That's this constant over here, which is, of course, 1. Okay, this thing here. And then the turning point is at x equals minus b on 2a. Well, let's throw that in. Minus b minus 6 over 2 times a, which is 2 times 3, which is 6. 6 divided by 6 is 1. Subbing in when x equals 1 into my equation is going to give me that my turning point at 1 minus 2, which of course is exactly halfway between the two x-intercepts. And we're looking at there, and let's all sketch this together. Okay, goes down here, sort of turns there, and as you can see, it goes up like that. And we've got all of our key points in here, and that's how you sketch these things. It takes a fair bit of work, and this is, by the way, this is sort of finishing off the sketching of parabolas. So just remember that when you're sketching parabolas, there's three ways. We've got factorizing. Okay, and when you factorize, we're looking and we find our intercepts, then the turning point is exactly halfway between the two intercepts. That's one way of doing it. We then look at completing the square, and completing the square gets us into this turning point form, okay, which is of course this going to be looking at this, and then we could find our turning point and intercept that way. And now we're looking at the quadratic equation. So if it doesn't make sense to factorize, if it's really something that's tricky to factorize, we can't factorize. And if completing the square in particular, because we've got a non-monic, is not really doable, then we're going to have to use the quadratic equation. And of course, when doing that, you need to be able to use the rule, which is finding the turning point. Is the x part is at minus b on 2a. And of course, you're going to have that quadratic equation handy somewhere. Okay, and then of course you can work out what the discriminant is. That's also going to tell you how many x-intercepts there are. Fair bit. You're going to need to practice this a lot. And look, I hope that you at least started to make some sense of it, but you're not going to really make full sense of this until you practice this many, many times. I really encourage you, once you get a bit of a grasp on this, then to try some of the test yourself questions at the end of these notes. All right, thanks everyone. I'll see you in class.